You're watching TelecomTV's exclusive video coverage of the NGMN industry event from Frankfurt. And joining me now is Mike Kotkamp, who is Technology Manager Wireless at Rohde Schwarz. Mike, thanks for joining us on TelecomTV. As a test and measurement company, how is Rohde Schwarz involved in the 5G process?
All right, so from a test and measurement perspective, of course, we are involved in all these early research, pre-development work because luckily for us, people need to verify equipment they try to build, and that needs to be done even before we know exactly what it's going to be. So there are many of projects together with our key customers in the infrastructure, ships, terminal environment, where we do bilateral projects, of course, and try to understand what they need and help them in realizing things. That is one part of the story. And of course, there are all these more general projects running around the world. There's a 5GIC project, a research project in UK. There's this NGMN initiative. There is 5G Future Forum in China. And Horizon 2020 projects, they have just been approved. We are part of those as well. So you see, we are trying to get ourselves involved in the essential areas.
It must seem at times that we put the cart before the horse because your measurement equipment has to be there and ready to test new 5G technology, just as it's been developed.
Yeah, I mean, of course, you need to be flexible in your solution space, let's say. But luckily, of course, in test management, you have got a little bit more freedom, and you have equipment which is broader in types of applications they can satisfy. I mean, we are not serving only cellular, so serving these type of equipment in different areas. So we are used to higher frequency, taking that as an example. We are used to higher bandwidth to take that example. And of course, we can offer solutions which are maybe not tailored to a very precise spec, which is not existing yet. But we can, of course, play around with our equipment to learn about these new areas. And that's how we get involved, usually.
So at some time in its life cycle, 5G is going to be used with higher frequencies. What added complications will this bring?
Yeah, of course. I mean, it's really true that below 6 gigahertz, we've got a fairly good knowledge, of course, from history, how cellular works in these environments. And we don't have that much of experience, of course, at these higher frequencies. And maybe the central problem is now not the absolute frequency, because, as I said, we can work in 60, 70, 100 gigahertz. But the range that is discussed right now is kind of 10 to 90 or 100, whatever you would like. And that's maybe more difficult to say, where is it, or where is a priority band to start off with. But equipment is, at this early stage, general enough to go up to, let's say, 40, 60 gigahertz already today. So we can play around it up to these frequency ranges. You can do a little bit of external mixing process to go up even higher. So yeah, it's not the same level of precise and test uncertainty we are used to in LTE at 2.1 or 2.6 gigahertz we are used to. But you can work already. But it's more complicated. You are absolutely right, and higher frequency very differently behave in terms of propagation. That is another very important subject, by the way, to sound the environment, to sound the propagation conditions at these frequencies. We don't know so much than we know in GSM or UMTS LTE.
And in terms of propagation, with 5G, we're going to have denser networks. What issues are we going to have with signal scattering?
It's very different. I mean, 60 gigahertz is a little bit more known because of the wireless AED experience we are having there, and we have some of course, different behavior of walls, of even glass, where we usually think it's going to be good for lower frequency, but it is perfect shielding at the end for higher frequencies. So you need to learn about that, and in terms of delay spreads, how many passes you are going to see, which you can accommodate in your receiver to really take the most energy out of the signal you receive. That needs to be known, first of all, for implementing the receivers in real equipment. And also in the test world, we need to create channel models, because we don't want to have, we want to have a real reflection of the environment in the lab to be able to do all the testing very efficiently. We don't have these channel models. You need to do field testing all the time. That is much more expensive, so you cannot afford that. So it's very important to know the environment, understand it, develop the channel models out of that.
How important is industry collaboration throughout this process, feeding back results, avoiding regional differences in the development of 5G?
Yeah, I mean, standardization is, of course, key. And from experience in the past, we know that it's very good to have this global standard. And then many people are promoting it, and certainly we are also behind this, to have a global agreement. It's difficult if more and more people are having to agree on something, but and it may be a longer process at the very end, but certainly it's good to have this global harmonization. And this also takes spectrum into consideration to have, as far as possible, harmonized bands. Certainly this cannot be one band, but at least to have a kind of priority bands or most important bands to be named and written down somewhere, which eases these things. And yes, standardization is key, has to be done. And this is maybe the work still to come, of course. We have seen many ideas this week, and the use cases are known so far, but then nailing it down to something more concrete, how these different technology components play together to form the actual 5G system. I think this is still to come in the next 2-3 years.
Mike, thanks for joining us on TelecomTV.
You're welcome.